Today we're going to be talking about graphing tangent and cotangent functions. By the end of this video, you should be able to graph tangent and cotangent functions, and you should be able to state the domain and range. First, let's go back to the unit circle. Let's look at these angles. We know that the coordinate for 0 and 2 pi is 1, 0. For pi over 2, we have 0, 1. Pi is negative 1, 0. 3 pi over 2 is 0, negative 1. These are the points that we used when we graphed sine and cosine functions. Well, we are also going to take a look at pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. I'm going to make a t-chart where we have theta, tangent of theta, and cotangent of theta. So remember that tangent is sine divided by cosine, or y divided by x. So if we are looking for the tangent of each of these angles, tangent is going to be the y-coordinate divided by the x-coordinate. So this would be 0. At pi over 4, the coordinate is square root of 2 over 2, square root of 2 over 2. So the tangent is 1. At pi over 2, we have 1 divided by 0, so tangent is undefined. 3 pi over 4, we have negative 1. Then 0, 1, undefined, negative 1, and 0. Cotangent is the inverse of all of these values for tangent. So 1 divided by 0 would be undefined. 1 divided by 1 is 1. The reciprocal of undefined would be 0. So you'll notice that these values are different from the values for sine and cosine for two reasons. One, we have some undefined values, and at those values we are going to have vertical asymptotes on our graphs. The other thing that you'll notice is a difference in the period. For tangent, the pattern goes 0, 1, undefined, negative 1, 0, 1, undefined, negative 1. Same thing with cotangent. We have undefined 1, 0, negative 1, undefined 1, 0, negative 1. Both of the patterns start repeating when we get to pi. This means that the period for the tangent and cotangent functions is pi instead of 2 pi. So let's take a look at the graphs. We are going to label our axes the same way that we did for sine and cosine. Now, if you look back at the t-chart that we created on the previous slide, we are going to graph those points, remembering that any time it says undefined, that is a vertical asymptote. So we have 0, 0, pi over 4, 1. Then we have an asymptote. Then -1, 0, 1, asymptote, -1, 0, and the pattern will continue because we can just keep going around the circle and looking at the values for coterminal angles. So when we connect these points, the important thing to remember is that these are curves, not straight lines. So make sure your graphs curve. Now, when we look at the first period for the graph, generally we are looking at this period of the graph, the one that is centered at 0. Now, the domain and range for tangent functions are a little bit different. Since we have asymptotes, the domain is a little bit trickier. I'm going to write it in set notation. We have the set of all x's, because it's a domain, such that x does not equal the asymptotes. Well, if we continue this graph on forever, we will have an infinite number of asymptotes. So we are going to write this as x does not equal pi over 2 or any pi after that. So we're going to call that plus k times pi, where k is an integer. So this is the symbol for the integers. It is a z with 2 diagonal lines. So this means that you can plug in any integer for k and find the value of an asymptote. So that could be pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. We could plug in negative values for k and have negative pi over 2, negative 3 pi over 2, etc. The range for the tangent function is easy. That's just going to be all real numbers, or if you prefer interval notation, negative infinity to infinity. Now let's do the same thing for the cotangent function. We're going to label our axes the same way we've been labeling them. And then we're going to use this table that we created to graph the function. Remember that undefined values are vertical asymptotes. So here we have a vertical asymptote at 0. Then it goes 1, 0, -1. Another vertical asymptote, 1, 0, -1. And we can continue on the negative side as well. Again, when we connect the points, they need to curve. When we look at the first period for the cotangent function, that is this curve between 0 and pi. When we write out the domain and range, it will be similar to that of the tangent function. Our domain is going to be x, such that x does not equal the vertical asymptotes. Here, the vertical asymptotes are all multiples of pi. We have 1 pi, 2 pi, 3 pi, negative pi. All of those values are asymptotes. So we can just say that x does not equal k pi, where k is an integer. And then the range is all real numbers, or negative infinity to infinity. So those are our basic graphs for tangent and cotangent. Now, for tangent and cotangent, we do not talk about amplitude. Amplitude is just for sine and cosine when we are looking at how tall the sine and cosine curves are. Here, we still have an a value that will stretch the graph, but we're not going to call it the amplitude. So our standard form for tangent and cotangent look the same as they did for sine and cosine. The first thing you should do when trying to graph tangent or cotangent is find out where the asymptotes are. In the original function for tangent, our asymptotes were at pi over 2, 3 pi over 2, 5 pi over 2. But for the first period, our asymptotes are at negative pi over 2 and positive pi over 2. So, to find the asymptotes, you need to take bx minus c, set it equal to the asymptotes in the standard tangent function, and then solve. So you get x equals the asymptotes. Similarly for cotangent, in our first period, the asymptotes are at 0 and pi. So we're going to take the part inside the parenthesis, bx minus c, set it equal to 0 and pi, and then solve for x. And that will give us our asymptotes. Now, we are still going to talk about stretching the function, which is determined by our a value. The period is going to be determined the same way that we figured it out for sine and cosine, but since the period for cotangent and tangent is just pi, the period is going to be pi divided by b. And we can still talk about quarter period. That'll be helpful. And it's just the period divided by 4. The horizontal shift is going to be c over b, just like it was for sine and cosine. And the vertical shift is d. So let's look at a few examples. We want to sketch one period for this graph. We have a tangent function, so we need to find the two asymptotes for this function. So we need to take bx minus c and set it equal to negative pi over 2 and positive pi over 2. In this case, we have x over 2 so we just multiply both sides by 2 and we get x equals negative pi and x equals positive pi. Our a value here is 1, so we are not stretching the graph. The period is pi divided by 1/2, which is 2 pi. the quarter period is going to be 2 pi divided by 4, which is pi over 2. We have no horizontal shift and no vertical shift. So let's start by labeling our axes. Then we need to graph our asymptotes. We have asymptotes at negative pi and positive pi. Now, if you remember, the graph of a tangent function has what I'm going to describe as a positive slope, whereas the cotangent function has a negative slope. So when we're graphing, we need to make sure that we have a positive sloping curve. So we know that our quarter period is pi over 2, so we need to have a mark at every pi over 2. The middle between the asymptotes is where the 0 is, and then halfway between the asymptote and that 0 point is where we have our other 2 points. And you can see that each of these points is pi over 2 apart. From the asymptote to the first point is pi over 2, from the asymptote. From this first point to the second point is pi over 2, from the second point to the third point is pi over 2, and from the third point to the asymptote is pi over 2. Then we just draw in our curve. And that's our graph. If we write out our domain for this function, we would say that our domain is x, such that x does not equal the asymptotes. When I write out this part for the asymptotes, I'm going to pick one of the two that I have already graphed. I'm going to just do pi, because it's a positive value. And then say plus the period times k. So it's 2 pi k, where k is an integer. I'm not going to write the range for most of these because the range is always all real numbers. Let's take a look at the next example. Here we have b of x equals negative 3 tangent of 2x. So first we need to find our asymptotes. We're going to do 2x equals negative pi over 2, and 2x equals positive pi over 2. So if we divide by 2, we get x equals negative pi over 4, and x equals positive pi over 4 as our asymptotes. Our a value is negative 3, which means we are going to flip the graph. The period is pi divided by b, which is 2. So the quarter period is pi over 2 divided by 4, or pi over 8. And we have no horizontal and vertical shift in this graph. So let's go ahead and label our axes. Then we'll graph our asymptotes. Since our a value is negative 3, we are going to flip the graph so that it is decreasing. It has a negative slope on this curve. Since our quarter period is pi over 8, I need to have points about halfway between this block. And since a is negative 3, then that means that these next 2 points need to be at positive and negative 3. So I'm going to extend my axes a little bit. And then connect the points in a very skinny curve. And that's our graph. The domain for this function is going to be x such that x does not equal one of the asymptotes plus the period times k, where k is an integer. Next, we have c of x equals 2 cotangent of x over 3. So we need to find our asymptotes first. This time we have a cotangent function, so we need x over 3 equals 0 and x over 3 equals pi. If we multiply by 3, we get x equals 0 and x equals 3 pi as our asymptotes. Here, our a value is 2. The period is going to be pi divided by 1/3, which is 3 pi. So our quarter period is 3 pi over 4. And we do not have a horizontal or vertical shift here. So now we need to label our axes. We're going to graph our asymptotes first, which are at 0 and 3 pi. Since our quarter period is 3 pi over 4, that means I need to have a point every 3 pi over 4. Since we have a graph of cotangent, we're going to have a negative slope. And since the a value is 2, that means that the first point at 3 pi over 4 is going to have a y value of 2. The next point is going to be another 3 pi over 4 at 0. The next one is going to be 3 pi over 4 from there and at negative 2. Then we just connect the points in what is a rather wide curve this time. And that's our graph. When we write the domain, we have x such that x does not equal one of the asymptotes plus the period times k. I'm going to do a little shortcut here and just say 3 pi k. Technically this is the same as saying 0 as my asymptote plus 3 pi, which is the period, times k, where k is an integer. And again, the range is all real numbers. Lastly, we have d of x equals tangent 2x minus pi. We have a tangent function again, so we need to take the part in the parenthesis, 2x minus pi, set it equal to negative pi over 2 and positive pi over 2. So we need to add pi to both sides and divide. And then we have our asymptotes. For this function, our a value is 1. The period is pi over b, which is 2, so pi over 2. The quarter period would be pi over 8. This time we have a horizontal shift of c divided by b, so pi over 2, so we're going to the right. And we do not have a vertical shift. So let's label our axes. And then draw our asymptotes. So the distance between our asymptotes is equal to the period, which is pi over 2. Since we have a tangent function, we are going to have a positive slope to our graph. And our a value is 1, so there is no stretch. Now, finding the asymptotes takes care of this horizontal shift, because the first point, which was originally 0, 0, has now shifted pi over 2 to the right. So then we just connect our points. And then we have our graph. The domain for this function, we have x such that x does not equal one of the asymptotes plus the period times k, where k is an integer. And that's it.